So like I said, my name is Asaf, and I'm the founder of Logs.io. What we do is observability for open source. And I'll talk very, very little bit about what we do, but mostly about how to structure it in a dynamic environment. I said before, I live in Israel, father of 2 kids, also a pilot, and an engineer at heart. So it's the only thing I've ever learned I've ever studied is how to be an engineer, how to code, how to write code. So that's what I do. We're going to talk about kind of like what is observability, and I'll try to make it engaging and ask some questions. If you feel it's too much, then you don't have to. Talk about open source, telemetry, open source in Kubernetes, and also talk a little bit about security, which we feel a lot of time is being left out, and only in hindsight being captured, which I think it's an issue that definitely needs to be covered. And at the end, I'm going to show how to put it all together, how to bring this telemetry built on open source to life in a production environment. If you do want to hear more about us, we're in booth 2213 in the Venetian, which I think is the main hall. I know there's a show floor here as well, but we're in booth 2213, and if you want to come by our booth and learn a little bit more about what we do. So how many here have heard the word observability being used? Great. So it seems like this is the new term, and a lot of people hear about it. Definitely, it's been communicated a lot. And the question that we ask ourselves all the time is like, what is this? Is this like a new term for monitoring? Because we were doing monitoring before, and now we call the same thing observability. Is it about collecting logs, metric, and traces, the trinity of observability, doing that, or is it about something else? So one definition which I personally like the most is the definition from Wikipedia, which says that observability is a measure of how well internal state of a system can be inferred from knowledge of its external outputs, which means we have a system, and it doesn't have to be the code that we wrote. It could be a car or a plane that we're flying or our own body, and we want to know what's going on inside, and how well can we determine the internal situation by collecting information from outside. So you all know when we're sick, we're taking temperature, blood pressure, heart rate, and then we know that we're sick. And same thing with the car, it overheats, you know what's going on, and same thing with other things. Same applies for our environment. So we write code, we deploy to production. It doesn't always work. Sometimes there is bugs, there are issues, sometimes there are scenarios which we didn't expect. And obviously, we cannot see what the code is doing. So the question is, how well did we instrument it? How well did we build the ability to know what's going on inside as quickly as possible and to troubleshoot it as quickly as possible just by looking at external signals? So there are commonly known 3 different ways of collecting data that provide this observability, provide this way of knowing what's going on inside the system by looking at the outside metrics. The first, and I think the most primal one, is logs. Everybody writes logs. Everybody who writes code, the first thing he writes when he writes a method or a function or whatever is write the log what's going on. This is how the machines are communicating with us, the people who write the code. So this is the basic one. The biggest challenge with logs is mostly unstructured data, which is easy for us to read if we need to read 10, 20, 50 lines, but reading through tens of millions of lines of logs to understand what's going on, it can be very difficult. So it is easier to collect. It is harder to interpret and understand what's going on. The second thing around here is metrics. So metrics is mostly being used for infrastructure monitoring. So how my server is performing, the CPU, the memory, and the disk space, the network, and how everything is performing, and down to custom metrics. So from my own code, I can instrument it and say, hey, I count the number of errors that are happening, the number of sessions, everything around counting information, so I can track this and I can see trends and I can see what's going on. So metrics require a little additional work to collect than logs. but it provides an information which is easily visible on a grand level. So I can look at the graph and I can see, even if I have 100 pods in my Kubernetes environment, and if I have a cluster of 50 nodes, 100 nodes, and they're running across different regions and across even maybe different clouds, I can still look at one graph that can tell me what's going on because I collected this information. So it does require a little bit more work to get this information, but it does give you information of what's going on. The challenge with metrics is that you can get an indication that something is wrong, but it doesn't tell you the whole story because it's only built on the information that you collected. Eventually, if you want to know the whole story resides in the logs. The third, kind of like the third leg in this chair of observability is the traces. So traces, or what's commonly known as APM, is the ability to instrument the code and say, hey, this transaction took 100 milliseconds and it included 3 times access to the database, which every time we access the database, it's another 10 milliseconds, and these are everything that's happening in the transaction. It's the heaviest one of everything because you need to instrument the code, which means that the codes run a little bit slower, and it requires a lot of work to get it done. It's also a lot of information. This is why when we see organizations, we usually see them tackle logs first, tackles metrics second in getting the information, and tracing only comes as a third. So if I'm using metrics and logs to mainly look at the availability of my system, the usage of traces is usually around performance. So now I know the system is operating properly. I want to make sure that it's performing well, and I want to make sure that I optimize it for everything that's going on. Who cares about observability? The main people who care about observability is us, the engineers who write the system and want to maintain it and do not want to wake up at night and figure out that we woke up for something which can fix itself. We do not want to wake up at night for something that now we have to investigate and wake up 10 other people in our organization that can help triage this because we didn't instrument things right. So I would say that the first people who care about observability and doing it right is the operators. Obviously, it affects the business and the end users, which kind of comes back to us, because if the business is not happy, if the transactions are not being processed correctly, if users are complaining because they cannot access a feature, if something is not working, that affects kind of like our life and the way we operate. So I think all of it comes back to the people who write the code, the people who monitor the environment, the people who care that the system is operational at all time. We live in a world that the expectation is that everything is going to be operational 24/7 without any interruption. This is kind of like almost a new world that evolved over the past 10 years or so. We weren't used to live in this world. So systems were not like, stores were not open 24/7. Before the online world, obviously, which happened a long time ago. But now the expectation is from everything that's going to happen this way, from video streaming to car sharing, ride sharing, and everything has to be operational all the time. Otherwise, a very small interruption of operation, even Facebook, which is by all means an entertainment platform, there is a huge impact if the service go down or if something is affecting it. A few kind of like impediments of observability, and the first two are pretty obvious. So obviously, if I'm not collecting enough information or I'm not collecting information which is actionable, then this is kind of like a waste of my time because I can't troubleshoot and I can't know what's going on in the system. But the second two are actually more prevalent in distributed environment. So everybody knows if you connect Prometheus to a Kubernetes environment or you connect Fluentd and start getting the logs, you are flooded with information. Like a lot of data that mostly you don't need and you don't need to know about it. But the overload of information makes it harder to troubleshoot, harder to understand what's going on, and harder to have an observability system. The other thing is a fragmented access to the information. So I can get access to the information sometimes I can't get it. I cannot know some pieces of information. It's very important when we instrument a Kubernetes cluster, or we can instrument our own code, even if it's We instrument a Lambda function. Anything which is transient makes it difficult to track. Where is it running now? Is it like on this region, on that region, which availability zone? Is it part of this cluster? Is it running part of the production, part of the development, part of the staging? Everything gets all mixed up, and it's really, really important to create this alignment in the data that we collect to give us the ability to observe it properly and know what's going on. There are a few challenges that have been introduced by Kubernetes and Docker and serverless environments. And who here runs Kubernetes in production environments? That's a lot. So one of the things we do every year, we run kind of like a DevOps survey, and we survey a few thousands of people about trends in the industry. And it's pretty clear that the adoption of Kubernetes and the adoption of Docker is probably like 6 or 7 times faster than the adoption of the cloud. We run into a lot of organizations that they run on-prem and they run Kubernetes, and that's kind of like the what we do here, and kind of like how we see the complexity here in this environment. And there are a few layers of complexity around Kubernetes. One of them, and I think the most important one, it's dynamic. So containers are immutable, ephemeral. They run, they start, they stop, they restart themselves. Every time there is a problem, the whole pod goes down, goes up. Every time there is a version upgrade, I know in our environment in Logs.io, we upgrade between 50 and 100 times a day. Every time a developer clicks enter, it goes straight to production, obviously to all the automated testing, but it goes straight to production, and all the environments are being upgraded. All of our cloud deployments and the clusters that we support are all being upgraded at the same time. So this is something that's happening. The dynamic nature makes it very difficult to track. The key here is data persistency. Obviously, in a dynamic environment, if you don't collect the data in real time, then you don't have it. So if you get woken up by an issue that happened at 2 a.m. in the morning, and that pod has already been restarted and you don't have the data, you have no way of understanding what's going on. So you can hope for it to happen again, or should I say hope for it to not happen again, but without collecting the data and persisting the information in real time, it makes it really impossible to understand what's going on. The second nature of it and the challenge of it is it's distributed. So people run Kubernetes environments both on-premise and in the cloud. It's completely distributed, completely abstracted from everything that we do. And if you look into our environment, we're deployed both on AWS and on Azure. We have 7 regions on AWS, we have 5 regions on Azure. We do all these things and we coordinate all of it, and it's a completely distributed environment, and data flows between this completely transparently. If you look at kind of like where we've been and how we've kind of progressed, so many years ago, maybe not so many years ago, but traditional environment created like a monolithic architecture. Everything was on one server, but a hosting or whatever, and it was easy to know what's going on. You SSH into the server and you see everything that's going on. You don't need to go far. And the container architecture created another level of abstraction, which really helped us as developers, because all we want to do is write code. We don't care that much where the code is being deployed. It makes it very efficient for developers to do it, make it very difficult for operators to monitor it. But creating this kind of like containerized architecture created another level of complexity. The third level of complexity by adding a Kubernetes into it, obviously as developers, it creates full flexibility. Now we don't have to worry about scale. We don't need to worry about version upgrades. We don't need to worry about anything. All we need to worry about is to write the code. And someone else, which obviously goes back to us, needs to monitor this environment. And by creating abstraction layers which helping developer develop faster, we're creating complexity on the ability to observe it and to monitor it, which is always in the world there is like a balance between things. So we kind of like over-rotate and make it very, very easy for us to write code. We pack it in a Docker container with the operating system, with everything it needs, very tiny piece of code that just does what it's supposed to do. We deploy it in in kind of like an abstracted way into a Kubernetes cluster. It's running on all the nodes, and it's running in different pods and stuff like that, and that's it. We don't need to worry about version upgrade. Every time we upgrade a version, it happens automatically, sort of, and every time we want to scale it, it scales up, scales down. It's like magic, but the ability to monitor it can be challenging. The last thing is that it's verbose and noisy. So I talked to him before, and like if you deploy it in the environment, the moment you connect data into it, it's a very exhilarating moment. You start seeing data flowing up. You see you connect it to Fluentd, you connect it to Prometheus, and now you see a lot of like really, really nice graph, but you actually see a lot of data. And you see all this data makes it really, really hard to understand what's going on, especially when things break. The nature of things that break is the nature of like everything is like it's like a storm. And I'm sure all of you, or some of you, have been in a situation where some piece of the environment breaks, whether it's an infrastructure problem, whether it's a problem in the code, and suddenly things don't connect. Now there's a problem here. Now there's external latency here, and it's really hard to understand what's going on, mainly because of the kind of like the overload of the information and everything around that. So open source for telemetry success. So this is a survey that was done by Detanize, and according to them, 85% of companies are using open source to monitor their environments. Who here is using open source to monitor, whether it's Prometheus, ELK, Jaeger, Grafana, stuff like that? All of the above. So I'll talk about it in a minute, kind of like why it happens. But one of the things, I mean, we all know that like we may not know what's going to be like the next big thing, and whether and I'm sure a lot of people didn't predict that like Netflix is going to come and do the video streaming, and Uber is going to come and do the car ride share. And we do know a few things about what's going to come next. We do know it is going to be a software company. So whether they're going to stream videos, drive cars, deliver food, whatever, is going to be a software company. So everything in this world today is based on software and scalability. We do know it's going to run in the cloud, because that's kind of like gives the ability for scalability in a very short period of time, and the capital efficiency to be able to do it. We do know that most cases it's going to be an environment that's going to have CI/CD, so continuous integration, continuous deployment, which is by definition going to mean that they were going to run on Docker and Kubernetes. They can run on different flavors of it. They can run on different orchestration environment. They can run on other things, but it is going to run, and I'm going to use Kubernetes as a generic term for kind of orchestration the environment. So if it's going to run on that, we also know that it's going to run on open source, because the only way for today to establish these components is by open source. You cannot go anymore to a specific vendor and say, hey, I want to have the IBM version of Kubernetes or the Oracle version of Docker or anything. It just doesn't exist. There is one open source. Everybody supports the same thing. Full democratization of software, and where if 10 or 15 years ago I could run a web server from an open source one, I can write one from each of the proprietary vendor. It just doesn't exist anymore. And so we do know all these components. The other thing we know is that these companies are going to at least start their monitoring journey with open source, because they built on open source. They're built on Docker and Kubernetes. They're built on the cloud. And these tools, by definition, come with open source monitoring integrated into them. So that's kind of like what we know. So the biggest question is like why open source is more powerful. And obviously, I mean, you've seen, and there was just interesting a research that came out today by 451 research, Nancy Goring, which she explained kind of like the accelerated adoption of open source, especially around the monitoring aspect of it. And it's very interesting to read that. But a lot of it has to do with, first of all, accessibility. So it's readily available. I can just go to GitHub. I can just go to any website and download it, and now I have it working. I don't know how many of you have set up an ELK stack or Grafana with Prometheus. It works like magic. Like you download it, you build it, you run it, and that's it. It's very basic to do. The basic stuff is really fun to do as engineers. So it is accessible. There is a large community. So the community creates a few things. First of all, it creates the familiarity. So if we guys want to hire engineers, it's more likely that they would have access and they would know how to use open source tool than they would know how to use proprietary tool. It also creates the ability of content. So there is community, and people have already developed dashboards for ELK, for Prometheus, around Kubernetes, around Docker, around AWS, around any cloud provider that exists. The community already developed it because it's an open source, and there is a kind of sense of community, which I think we all like as human beings. It is DevOps native, so it means that it already integrated with the open source project. So the people who develop Kubernetes and Docker and Kafka and Elasticsearch and all these things, the way they monitor their environment is by using open source tool, because they're open source developers. So all of these capabilities, they already come with integrated connectivity inside them. You don't need to work for it. I mean, if you deploy Kubernetes, it's already, with Prometheus, just one line and you have it all deployed. It's self-discovered and everything is fine. Same thing with ELK and FluentD. Kubernetes comes with FluentD inside. That's it. Like, you don't have to figure out how to extract the data from it. You just have a FluentD endpoint and you have the data straight to your Elk stack or whatever you want to use. They're also cloud native. So again, this is something that I have to do with the people that developed the open source. So this is the most common toolkits that people use for their environment. And we talk about logging. I think by far ELK stack is the predominant logging solution for open source. ELK, Elasticsearch, Logstash, Kibana, and Bits. We see more and more people using FluentD, which they call it the EFK. So Elasticsearch, FluentD, and Kibana. We started to see some customers using, or some people that we see in the around using Loki, which is from the Grafana folks. But these are like the leading one on the logging. On the metrics and monitoring and kind of like the APM space, I think Prometheus is probably like the king of monitoring. We see it all over. The adoption is obviously being increased since the kind of like the vast adoption of Kubernetes. Graphite, another good project, less maintained these days, but definitely a good project. See a little bit of InfluxDB, and surprisingly enough, we see quite a lot of customers using Elasticsearch as a monitoring database. The reason they use it from a monitoring database is not because it's the best one, but it's because they have already familiarity from the logging. So they already say, hey, I know how to run Elasticsearch at scale. I know how to deploy it. It can support metrics. Maybe it's not the ideal solution, but it does the job. And Elasticsearch, the database, have gone significant leaps in the previous versions to make it work better with metrics. Grafana, by far, the main user interface for metrics. We rarely see anything other than Grafana. There's some Prometheus UI, obviously, and other stuff, but Grafana is the leading one. Definitely a great product and a great company, and very aesthetic in the way it looks and speed and everything. Tracing and APM, relatively new addition to the open source observability toolkit. Two leading products that we see often are Jaeger and Zipkin, both members of the open tracing format or the community. There are others out there. We see more and more adoption of Jaeger. And Jaeger it's a project that was done by a few engineers in Uber. And we see more and more adoption. Part of the reason it's more adopted is because it also supports Zipkin. So if you deploy a Jaeger server, it can also support the Zipkin format. We see Zipkin every now and then. Definitely both of them support the open tracing and everything around that. Another thing which we're starting to see more in the metrics and especially is a database also developed by a few folks from Uber called M3DB. This company, I think they just raised some money to build it as a full metrics database. But the beauty of M3DB is that it supports both Prometheus and Graphite format in parallel, which makes it very, very easy to use, and especially if you're using Grafana, which is the leading one. So this is what we see kind of like the toolkit and the open source observability. So the basic architecture, if you want to deploy it, and again, the talk is about Kubernetes. I say it's already come with Fluentd inside, deploying Jaeger, obviously on the code, and deploying the ability to collect it with Prometheus. That's the standard, the ability to get the data. Most companies, and this is kind of like a high-level overview, they send the logs and the unstructured data to Elasticsearch and Kibana. They send the structured data to a Prometheus backend or and Grafana. We see very few Graphite and InfluxDB, but it is out there. So it is there is the ability to monitor that. One thing that people usually leave out is security. I think we got used to, us as engineers, to only worry about the code and have someone else worry about security. And it's not the case anymore, especially with cloud and Docker and Kubernetes environment. And the reason it's not the same is because the threats and the type of security monitor has changed from an on-prem solution where I can protect the perimeter, I can put a firewall in place, and I can put something that's going to collect data from the endpoint devices, and everything, everybody's happy. Because of the transient nature of the environment, it doesn't apply anymore. So security is being left out. It's unfortunate it's being left out. We see more and more companies adopt the DevSecOps kind of like a terminology, and that's kind of like what they do. The reason it changed is also because of open source and the ability to download and to deploy things to production. So it's very hard to know that whether you downloaded a Docker image that includes some connectivity to a Bitcoin mining inside it, and it's going to run whatever it's going to run. There are so many Docker images out there to do all these simple things that we all want to do, and we all want to connect them all, and it's really hard to monitor stuff that we just downloaded and injected into our environment. So companies that we see using open source are building security, using open source tools for security, and using ELK as the base. So we can do threat enrichment, can do a lot of things with the ELK, obviously through a kind of like Logstash enrichment and other enrichment or Fluentd enrichment. And I think there are two kind of like leading products that we see on the open source data collection for security. Obviously, you connect to the cloud, so GuardDuty and CloudTrail logs are key things, as talking about AWS. If you're going to corporate networks, so environments like Suricata, which is also being deployed in the cloud, it's an open source network intrusion detection system, or Wazoo or OSSEC are two open source endpoint protection. So they provide compliance, they provide file integrity checking, they provide threat analysis and threat enrichment and stuff like that. The reality, it's not that difficult to deploy a security mechanism into an open source environment. It just required the mindset to actually do it and to deploy the right tools in place. And there are a few blogs on our website how to connect it all together and how to deploy it if you guys are interested. A few examples is, I'm sure you hear it every now and then. We hear about something that some security incident, something that happened, hackers that gain access to information and do this. I can tell you that we also run security for a lot of companies, and it's unbelievable how many people in this world are focused on trying to hack different systems. If you bring up a server which is open to the web, within a matter of seconds, you're going to get it, people trying to hack it, people trying to attack it, people try to, all sorts of things and exploit all the various vulnerabilities that exist there. It's shocking, so we do recommend people do it. Okay, so how do you go from like a very high level observability to make it production ready? I think one of the mistakes that people do when they build a production grade observability using open source is they need to realize that the availability of the monitoring system has to be above the availability of your production system, because you do not want to deploy it on the same servers. You do not want to deploy it on the same environment. You want to make sure that it's completely separate, because if you have an issue with production, and now your monitoring doesn't work because the production is down, then you haven't done anything really. So making sure that it's completely separate and making sure to maintain availability of it. If you deploy an open source observability, you also have to monitor that one, because it also has issues. So putting it all together, kind of like a very high-level production checklist. So it has to be resilient and reliable. So you have to be able to send the information and make sure that information gets there. Queuing the information, I'll talk about the architecture in a minute. Scalability. We all work in companies that grow. So companies these days grow much, much quicker than companies before. We experience companies that double themselves every year. And if you look at traditional companies, if they do 10% increase a year, they're very happy. So scalability is a key thing, and that's a contribution of the cloud, obviously. Performance monitoring and fine-tuning. So you set up your Elk stack, or your Prometheus and Grafana, or Jaeger. Now, you want to make sure that it's fast, because if you deploy it and every time you want to do it, it takes a few minutes to load the page, then you haven't done anything really. So performance and monitoring and fine-tuning it is a key thing. It requires some special expertise. Obviously, I talked about high availability and how to structure high availability. Archive and backups. Sometimes you do want to go back, especially for security use case, especially for operation. You want to know when it started. You want to go back. And security and compliance. We mustn't forget that if our environment is compliant and we have private information in our environment and we build an ELK stack, that information is going to get to the logs. And if that information is getting to the log, that means that our ELK stack also have to be secure and compliant, because otherwise it's going to go different places and you can't control it. So how to build it? So let's take it kind of like one by one and start with ELK. ELK is the most complicated one, but it does provide the basic for everything else. First thing is the ability to collect the data. I'm talking about here Docker, Kubernetes, and Wazoo, which is security information. Best way to collect the data on the ELK stack is using bits, part of the ELK family. And a lot of open source connectors to FluentBit and to FileBit and MetricBit and all these things are very easy to connect. You want to be able to queue it. The reason you want to be able to queue it is because you don't want to put the load of the monitoring on your own system. You want the one system to emit the information, forget about it. We have few customers that actually use UDP to send the information to us. They just don't want to deal with this information. They want to know the information got there and that's it. You definitely don't want to create a back pressure from your monitoring system into the production environment, because that's a bad idea, obviously. So creating a queue, most common one is Kafka. There are other queues. You can pipe it into AWS Kinesis. You can use Redis. We see Kafka as being the most common one to use. Second layer is parsing the data. Logstash obviously has to be hardened and operational. One of the challenges with the ELK stack is that if you send something which is not with the right format, then the ELK stack is saying, thank you very much, let's move to the next log line, and now you've lost one line. And that line could be the only line that you're looking for when you're trying to troubleshoot a problem. And losing data is not a good idea. So make sure Logstash is hardened. Make sure that you know how to deal with the dead letter queue. Make sure you know how to do it. You require some energy around that. Connecting Kibana, most common use cases are fronted with an Nginx. Proxy server, create user experience, create authentication, create the security that's not going to be open to everybody. That's the one thing. And then kind of like obviously monitoring it. There are a bunch of servers that you want to do. You want to run alert. There are open source tools to run alerts on ELK like ElastAlert. Archive it to S3, run the curator. I don't know if you guys are familiar with ELK, but the curator is the one that kind of like locks all the indices and deletes the old ones and does a bunch of backend jobs. So that's great. We built an ELK stack. Obviously, it has a little bit more component because you have to monitor it. You have to make sure that this is resilient. The ELK stack, if you're building just the Elasticsearch, you require 3 nodes, which for the master. So kind of like 3 nodes, and then as many data nodes as you need to kind of like obtain the data, but you want to run kind of 3 nodes. Now you have to replicate it all. And the reason you have to replicate it all is if you want to maintain higher availability than you have today, then you have to replicate it, and you have to use different availability zones. And Elasticsearch comes with the flag inside that called, I think it's called Availability Zone Aware or AWS Aware or something like that, that makes sure that when it does the replication, they sit, the shards sit on the different availability zone. It's great. It's going to make it more complex for you to understand the transfer cost between availability zone, but that's a different topic of how to monitor that. But this is something that is, obviously it's easy to replicate. You have everything set up, but it's a key thing. Obviously, when you run your environment, you can take shortcuts. They have implications on the shortcuts. So if you don't replicate the data, or if you don't run Elasticsearch on the recommended configuration, or you don't front it with Kafka, all of these things have implications on the performance, the availability, the scalability of it. It's up to you to make decisions, obviously, on your own environment and how you want to structure it and how you want to protect it. But this is kind of like a recommended for production. Setting the same thing on Prometheus. So this is kind of like one side of the, if you want to maintain it on a different availability zone, kind of like a recommended architecture. And the beautiful thing about Prometheus, it actually pulls the data, so you can control the pulling interval, and it actually slows down when the servers are busy. Deploying Prometheus servers and using alerts to manage the alerts. Obviously, it has a good connectivity to emails and PagerDuty, Slack, and what have you. So this is the kind of like the Prometheus, and obviously the most common data visualization is Grafana. Some people use the Prometheus web UI, also good, but less commonly used. Jaeger. How many people here are using Jaeger or doing tracing in production environment? Okay, so it's relatively fewer people that are using it. And I've talked about the reason when I started this, and obviously the reason is it is more complex to deploy. Require a lot of effort, slows down the environment, obviously, because now it's run within the kind of like JVM or what have you to collect information. But we do see more and more adoption of it. And I think a lot of it has to do with maturity of the organization, where you stand on the stack of addressing availability issues. If everything is running fine and you have auto remediation and all the alerts are being operated properly, then it's a good time to be able to go into trying to do performance optimization. It also has to do with the type of organization. Some organizations need that kind of like microsecond latencies, and they need the system to operate really fast. Some organization can deal with just scaling it horizontally. So yeah, if transaction takes a second and I need 1,000 transactions, I'm just going to deploy it on more servers, and I'm going to get the performance that I want, and that's it. because that's how I'm going to deal with performance, and it's fine that things take a second. Obviously, in some organizations, it doesn't apply, but we see it more and more being deployed in environment for companies that reach a certain maturity level with their observability stack, and for companies that require this from a performance perspective. One of the things that we found out at Log.io, for example, is that user response is really, really key, and how quickly a user in our system gets the data back, and the performance of it is really important for the satisfaction. So understanding the performance is obviously very important. Okay, so this was all like a nice story, and I told you all about it, and you can easily, for one of you have ever deployed ELK, Prometheus, or Jaeger, said in the beginning it's a lot of fun, and to do it. If you want to do it in production, you want to deploy it in such an environment. I didn't mention the fact that you need to upgrade it all the time, because the good people of Elasticsearch said, hey, you want a new version, just deploy the new version. Like, we don't care about the upgrades. There's like a whole list of breaking changes, you can deal with it. So doing an upgrade, same thing with Kibana and Grafana. So it is resource. So we do think, and we see a lot of organizations deploying this tool. It is worth it at the end of the day. It is worth it to be able to go with open source. It is easier to be able to connect to it. And the resource drain is just a matter of you allocating the time and the energy to do it, and not expecting it to be magic and say, hey, like it lives and that's it, and it's going to live forever, and I'm not going to touch it, I'm not going to maintain it, not going to monitor it. Tool sprawl is another thing. I think the environment is pretty settled on the tools that are being used. So ELK is definitely the predominant one around the logging. Prometheus, Grafana are predominant one around the monitoring. On the APM and the tracing, there is a little bit of different tools being used, but Jaeger and Zipkin are the two leading ones if you're ever choosing such tools. Yeah, so before I show you a quick demo, I'll just tell you a little bit about what we do. So what we do is we kind of like made it easy to do cloud observability with open source tools, and we've kind of like picked the best of breed tools to manage the environment and be able to do it, and you don't have to deploy it. So you can deploy the environment and you manage it, and you don't have to do it, and especially around Kubernetes. So I'm going to spend a few minutes on kind of like showing the demo of what to do at Log.io. And so what you see here is Grafana. So what we do is we basically take in the leading tools, which is ELK for logging and security, Grafana for monitoring, and Prometheus and Jaeger for tracing. We combine them all in one platform. Obviously, you can use whatever you want. And that's kind of like what we offer them as a cloud service. So you don't need to deal with maintaining it and version upgrades and scalability of it and everything around it. So this is Grafana. This is monitoring, kind of like part of our some of the demo environments. You see the nice graphs that you can create in Grafana, and the ability, again, if you can compress in a visual way, and that's the beauty of collecting metrics. You can compress in a visual way a lot of data into very kind of like a small view. And you can see here that I have an increase on my Nginx cluster. I can filter that one only, and I can see that information as it's relevant for me. And I can also see that it also impacts the memory, and filter that one as well. One integration that we provided, and this is not part of obviously of the open source tool, but the ability to troubleshoot quicker is something that we focus a lot on when we build a system. So one feature that we've added is the ability to explore the data in Kibana. So because we have all the information, obviously, so you can see the logs that are being populated in Kibana. And one of the things I see here is that there's also kind of like an increase of logs right at the same time where there was an increase in CPU and there was an increase in memory. So obviously there is an issue here. The ability to transition between the metrics view and the logs view, and I'll show the traces in a minute, is a really key thing in the ability to optimize the troubleshooting. When we work with environments and we work with customers or people that monitor their environments using open source, usually a lot of people put a lot of emphasis on being able on the detection part. I want to be alerted as quickly as I can, and as a result of it, they alert on everything. Everything that's wrong, they alert on, and obviously that creates a little bit of an alert fatigue because a lot of the things are correlated, and you don't need to alert on anything. You just need to alert on the first thing that kind of like impacted the environment, but that's what people do because they want to get alerted. They don't put enough focus on the ability to troubleshoot quicker. So we have so many monitoring tools. I can tell you in our environment, so we have Nagios, and we have obviously Grafana and Prometheus, and we have alerts from ELK. When things are wrong, we know it's wrong. So, and I'm sure it applies to a lot of environment. And the question that we deal with at Logs.io is, okay, we have a lot of tools that tell me things are wrong. I know things are wrong, but now how quickly can I troubleshoot it? How quickly can I get to the bottom of it? How quickly can I resolve it and deploy a fix to production, or revert a fix, or understand what's going on? And that's what we focus on. So one thing is obviously to transition between the logs and the metrics. The ability to see it, the ability to see kind of like the errors and the exception in the logs. And quickly, you see that when I transition, it actually copied the query that was used in the metrics part to the logging part. So transition is very smooth between these tools. So I can clearly see it from here of kind of like what's going on. So this is one thing we did. Also integrated Jaeger into it. So just by the raise of hands here, I saw that not a lot of people have familiarity with Jaeger. Pretty cool open source, pretty nice to see. And if I want to drill down into a transaction and see what's going on here, I can drill down. It's very, very basic instrumentation. And these guys did an amazing job. I heard a lecture of the guys who developed it, I think 2 years ago in Monitorama. It was like fascinating how everything is being done and how they use it. So Jaeger, one thing here that really jumps, you can see from here is I can see that all my Redis calls are serialized. So obviously there is no need to serialize calls most cases. Most database calls, so I can basically reduce the time for this transaction to exist in Jaeger. Another thing which Jaeger gives me the ability is if I want to compare different transactions that happen, I can just compare them, and I can see how they're different and how logical can I get this information. So again, a very powerful tool, and this is kind of like stuff that we offer as a service. So kind of like jumping back on Kibana and the ability to create the metrics and the ability to link all the story together. So obviously you can build it on your own. It's a lot of fun to build it on your own. I have to admit, it's a lot of fun putting it all together. It feels like magic when it works, and you actually get like a really, really, really good system. This is not like I don't know how many of you have had the experience of seeing the UI of Nagios and stuff like that, which is not as cool as this one. But you actually get like a really cool system, and it's really, there's a lot of people behind it, and you can be behind it, and you can contribute code to it, and it's a lot of fun like building it on your own. And if you can afford to have the engineers to do it, if you can afford to spend the time to do it, and also maintain it and monitor it, because if this is monitoring your production environment, the basic thing to do is you want to monitor this. So you get a really, really nice system. What we do is we've taken all of this, and we give you the ability to enjoy all the great capabilities that you can get from Grafana, that you can get from ELK, that you can get from Jaeger, without the need to work for it, without the need to actually deploy it and maintain it and host it and everything around that. And we've done, so I want to show you just one last capability that we've developed into Kibana. And that capability also, we're working really hard to understanding how to reduce troubleshooting time in production environment. And the last thing I kind of like want to show before I have Q&A is the log patterns. So obviously you can look at the data and you can see all the logs and you can read through them and understanding what's going on. And if you know exactly when things happen, that's great. But if you don't, one of the things we give you the ability is to click on the patterns. And now we basically shrink, we compress, we cluster all the logs that you have in the environment. This is being done in real time, but we cluster it into, instead of looking at 10 million log lines, now you're looking at 20 or 50 different lines of information. You can say, hey, this proxy request, I don't care about it, and I want to reduce the noise right now because I'm troubleshooting something. And you can remove that, and then you can say, hey, there's a transaction aborted that only happens 0.28% of the time, and I want to know what that is, and then see that information as how it pertains to you. So the ability to filter out the noise and the ability to quickly scan through and understand what's out of the ordinary here is something that we do, and we have other capabilities into developing things quicker and into troubleshooting things quicker. So that's what I have for today. I hope that you enjoyed. I mean, it is open if you have a question. We have 7 more minutes, so I don't know if you guys, yeah.
Sorry, you mentioned that Titans was something you were working on at logs.io.
Yeah.
Is that something you'll be feeding back upstream to Kibana as well?
It's so the challenge with it is that this is a whole engine that runs on our streaming service. So it is hard, but we do have a free service. So we have a free version that you can use that, and it is fully functional, fully capable. Yeah. Yeah.
Can you repeat the question?
The question that he asked is whether we're going to feed back the patterns and into Kibana. We do contribute a lot of code and content to Kibana, but some things are more difficult to contribute because we rely on other algorithms to run. Yeah.
So the question is, out of the specific platform, they really have their own implementation of Prometheus. As an example, they have their own implementation of Prometheus.
Yeah.
In those cases, how can we build a single version of observability, essentially, to monitor the whole end-to-end, including like the services as well as the APIs that are using any kind of like API-based platform?
So the question is like, yes, I'll repeat the question. So the question is whether if you have different versions of Prometheus or different implementation of Prometheus in different services, how do you obtain a single observability platform? So it's true that they have different versions and different implementations of it, but each one of them also comes with its own set of dashboards with Prometheus. So it's okay to be different, and in Grafana you can connect them all, and the beauty of a Grafana is that you can have Prometheus feed the data, you can have InfluxDB feed the data, you can have Elasticsearch feed the data, and they can all live on the same dashboard. It's completely transparent from the backend, so you can construct it on the Grafana side. Yeah. 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 Yeah, so the question is like, what's the difference between using the open source and using a company like us that provide the open source versus using Splunk, which can provide the same capabilities, but they say it's proprietary. So the main thing of open source is it is connected to all the open source capabilities that you guys are using today. So if you're using Docker and Kubernetes, it's by default, by design, being connected to it. The other thing is part of a community. So Splunk is a great product. It is a great product. The value of this company consists of the number of people that work in the company. They're the one developing the content. They're the one developing all the information. If you look at open source, there is a huge community. If you look at Grafana, how many dashboards and connectivities are out there, it's way more than you would get with Splunk. And the other thing is that recruitment. So the Splunk is a public company. They have 16,000 customers, 16,000 companies using an amazing product, really, really good product, good companies. You know how many companies are out there? I think 5 years ago, AWS said that they have 1 million companies using them. It was like 5 years ago. There are so many companies out there. The likelihood today of hiring someone with Kibana, Grafana, Prometheus expertise is way higher than hiring someone with a Splunk expertise. So now you have to teach them something that they're not going to use anywhere else. They're not going to be using it in other places. They're going to go with an open source probably. Because of the trends that we talked about, the Docker and the Kubernetes and the ability to run CI/CD and all this information and all the flow of open source that is surrounding us, that's going to be the future. So it's already happening. It's already taking a major trend there. So you can pick a good product, but if you want to hire better, if you want to care about the engineers, you want to be progressive on things, then definitely open source is the way to go. Yeah.
How do you authenticate users? How do you integrate with your customers' authentication systems like Open Directory and
Yeah, we have connectivity to Active Directories and SSO, and we actually use a third-party company. We use Auth0 and provide all the connectivity to AD and Azure AD and Okta, OneLogin, all that stuff. So it's pretty standard these days. Yeah.
Have you guys seen Druid at all?
Druid? Not really. Not that often we see it. We see it not as often as we see kind of like Grafana and Prometheus for this. I think because of, again, I think a lot of it happened because of the wide adoption of Kubernetes as opposed to Swarm or other instrumentation. And it already came with Fluentd and Prometheus inside and the ability to connect it. This is why it's not that it's like, it's great, but it's not way different than Graphite or InfluxDB or anything else. But it just got like widely adopted, so it's a trend that's happening. Yeah.
You spoke about security specifically, that sometimes it's overlooked in monitoring and logging solution.
Yeah.
What do you do different than what you do specifically?
So security related, so we do have a security product. And the beautiful thing is it relies on the exact same logs that you use for operation, especially if you're running on the cloud and the Kubernetes. So we do that. Security product, it's a full-out SIEM solution with hundreds of pre-made dashboards to investigate things and different rule mechanisms. So we do threat enrichment. So we enrich all the data with threat feeds that we either buy or we use open source threat feeds. So you can see all the different threat enrichment that you have here. We give you the ability to troubleshoot things quicker. And if you look at, let me see. So you see here, this is, for example, a dashboard that we built for that happened to one of our customers. And you see here that there is a lot of, this is an EC2 service, and you can see that when you look at kind of like the creation of start instances, you see that the user named Dana is increased, have like a high starting of instances, and you can see that specific user also has a lot of SSH connectivity. We provided the ability to navigate through, which is not part of the ELK, to see what that user has done. And by correlating this information, you can see that it detected by a suricata that's running that someone is connecting to a phishing URL. ODT, which we collect the data from the servers. You can see a lot of SSH connectivity. You can see CloudTrail that a lot of instances were started by the same users. And you can see from Zik, which is an IDS system, also an open source, that port scanning activity was detected. So this is kind of like a classic detection of Bitcoin mining that some users got either downloaded an email, and now you get the suricata get to a phishing URL, download something in the environment, and now starting up instances on AWS on your behalf, and someone else collecting the money for it. So this is what we do. This is what we do for security. So we have a full-blown SIEM solution, a cloud SIEM solution.
Is it something that is pre-built, or you need to do
It is pre-built. No, it's 100% pre-built. If there are things that you have we don't support, then we build it for you, but it is pre-built. So if you have like a security instance that we don't support, then we build it for you. Yeah. We're talking to Prometheus instances using Fluentd, so not Fluent, sorry, metric bit. So you can deploy metric bit to collect the data from Prometheus if it's running on Kubernetes, and you get the data. Inside.
How about the cloud native, for example, where the security feed is coming from? Your instrumentation or the existing instrumentation?
The security feeds, the threat detections. So these are all the feeds that we support. And you can see a description about them. You can edit them. Some of them we purchase. Some of them it's like open source one that we take the information to an API. So Alien Vault has a reputation database that you can look into, and emerging threats and blocklist.de and malware and all of these companies, they provide like a threat enrichment. And we do the enrichment internally using kind of like a sort of like a log stash. We do allow you to bring, yeah, you can do it, and we can have the analysts. We also have a team of analysts that kind of like research through the threats and understand them. But yeah.
Regulatory stuff for healthcare, so
Yeah, we are HIPAA, GDPR, PCI level 1.
you'll sign RBA.
Yeah, absolutely. We'll sign everything. We're used to that. It's I think HIPAA is the only one with I think a criminal implication to it. The other one are yeah. So we do have HIPAA. We do have a lot of companies that use us, like medical companies that use us already to do it. So Stanley Health is using us to monitor their like endpoint devices. So they have devices that check that every time a doctor goes into a room that everybody wash their hand using this alcohol gel or something. So. Exactly. So
How about execution of commands in response to alert rules?
So you can tie it back to an AWS Lambda function. So our alerting mechanism, any endpoint you can send it, you can tie it back to an AWS Lambda if you're running an AWS and execute a playbook or something like that. Yeah. Okay, great. Thank you very much. Hope to see you in our booth. Thanks.